Hi folks, in this video we're going to be looking at how to test PC power supplies like these ones. Faulty PC power supply can cause things like random crashes, freezes, can stop your PC from starting up at all, and in certain cases can even damage your PC's motherboard. So to test a PC power supply properly, what we need to do is look at the different voltage levels that are coming out of the power supply. And there are a number of different ways in which we can do this, but the voltages that we're going to be looking for are 12 volts, 5 volts, and 3.3 volts. And in this video, we'll be looking at 4 different methods for how we can do this. So let's get started with the first method. So to run the first kind of test, we're going to need to turn the PC off. Then we're going to turn it back on again. And we're then going to need to press a particular key on your keyboard numerous times until we can get into the BIOS. Okay, so as soon as you turn on your computer, start pressing the delete key continuously like this. On some systems it may be the escape key or it may be the F2 key, so just keep experimenting until you find out what works for your system. Either way, just keep tapping the key continuously until you see a screen something like this one. If you see a screen like this, it's possible you either didn't hit the right key or waited too long before pressing it, and we'll have to wait for Windows to finish loading and then shut it down and restart your PC. It's better to let Windows finish loading up rather than just turning your PC off in the middle of starting up. Anyway, if all went well, a few moments later you'll be brought into the BIOS where you'll see a screen similar to this one. This is a BIOS screen for an Asus motherboard. Your BIOS might look a little bit different, but should have similar options on it. To find the voltage readings, we just need to go into the advanced mode by clicking on the advanced mode button, or alternatively you can press F7. And straight away we can see the voltage levels right down here in the bottom right hand corner of the screen. And we can see that the 12 volt level is at 11.884, which is fine, it's pretty much close to 12 volts. The 5 volts level is at 4.980, so that's pretty good as well. And then the 3.3 volts supply is at 3.296, which again is pretty close to 3.3. So anywhere within about a 5% range would be fine. Once you start going over that, it might be starting to get a little bit dodgy. Maybe 10% might be okay as well, but I would be more inclined to be happy if it was within 5% of what it should be. Now you can also go up to the top up here and select monitor. This brings you into a more detailed screen with the various sensors showing things like the CPU temperature, motherboard temperature, and also the CPU core voltage, as well as the 3 main voltages that we're kind of interested in. Here we can see the CPU core voltage as 1.152 volts, which is actually fine. Anything under about 1.35 is perfectly fine. So this is a really handy and easy way of checking the power supply voltages in your system. So if you have this facility in your BIOS, you may not need to go on to the other methods, which I'll show you shortly. Also, this method will only work, obviously, if your PC is able to start. If your PC won't start, then you're going to need to use one of the other methods. So before we go on to method 2, here's an example of what the BIOS looks like on a Gigabyte motherboard for comparison. Again, pressing delete to get into it. So in this particular BIOS, we just go up to the MIT option, and then from here we can choose PC Health. So under PC Health, we can see that our CPU core voltage is 1.008 volt, which is okay, it's not too bad. And then we can see as well that our 3.3 volts is 3.383, so that's pretty close, not too bad. Our 5 volts is 5.070, so that's okay, that's fine. Our 12 volts is a little bit high, but it's not too bad, 12.384. So that's kind of okay. It's a cheaper power supply on this one, so it maybe not quite as good as the first one we looked at. Finally, for those of us who have a much older machine, you may get a screen like this one. In this case, we had to press F2 to get into the BIOS. Now, you can't use a mouse in this kind of screen, so we just have to use the arrow keys on the keyboard to get around. And in this case, in this particular BIOS, we just go to Advanced, and then we go down to Hardware Monitoring and press Enter. And here you can see the CPU temperature, the system fan speeds, and some of the voltages from the power supply. So plus 5 volts, plus 12 volts, and the 1.25 volts as well. Now, after all that, it is possible that your BIOS will not have the option to show you the different voltages from your power supply. In which case, then you'll have to use a different method to determine if the voltages are okay, and that's where we're going to be going on to method number 2. Okay, so for this method, we're going to use some software to have a look at the voltages on the system. So in this case, we're going to use a program called HWInfo, or HWInfo. You can download it from HWInfo.com. The software is free for personal non-commercial use, so to download it, just click on the free download button and choose a mirror to download it from. So once HWInfo is installed, just click on the icon to start the program, and then you'll get this screen here. So this screen is asking us, what do we want to do? Do we want to run all of the stuff in full mode, or do we just want to use the sensors? So for this particular situation, all we're really interested in is using the sensors. So I'm just going to select sensors only, and then click start. Now at this point, you can see that we have lots and lots of different measurements of different things like speeds and temperatures and so on. But what we want is to just go down to this part down here where we're actually looking at the motherboard. So in this case, I have an MSI MPG X570 Gaming Edge motherboard. And so we can see here different things such as the temperatures of different parts, but we can also see our voltage for the core, so 1.3, our 5 volts, our 3.3 volts, our plus 12 volts, and they're all shown here. And it shows us also the current voltage, the minimum that it's measured so far, the maximum that it's measured so far, and also an average value. And it even shows us things like the CMOS battery voltage. So this is a really handy program for checking out the voltages in your system. But again, obviously your system has to be working in order for you to be able to check this. So for method 3, we're going to use a multimeter. These are a handy tool you can get for about $15 or $20 or euros, and they're really handy in the workshop for testing things like voltages, for testing fuses, for measuring currents, and also for things like testing transistors. So a multimeter typically comes with a small display, a dial for adjusting what you want to use it for, a couple of probes for connecting to things so you can actually measure something. And for this particular video, we want to measure voltage, and we want to measure DC voltage. So if we look here on the dial, there's a selection here for DC voltage. Over here on the right, we have AC voltage, but we're not going to be measuring that with the power supply. And then there are some other areas like resistance down here with the omega symbol. But for the moment, what we want is voltage. So what we need to do is we need to set the meter to a value that's going to be a little bit higher than what our voltage is going to be from our power supply. So typically power supplies 12.5 volts is about the max they're supposed to be anyway. So if we set it to 20, that should be plenty for what we want to measure. Now, just to demonstrate how easy it is to use, I'm just going to show you this battery here. So this is a 9-volt battery, and I'm just going to test it by using the 2 probes. So I have my voltage already set to 20 volts on the meter, and then I'm just going to put the 2 probes onto the battery and see what reading we get. So we're getting 8.84. Now this is a 9-volt battery, and the 9-volt battery, when it's fresh and full, should be about 9.5 volts. So we can see that this battery is starting to kind of run out, and it won't be usable for much longer. So that's a great way to be able to test batteries really easily, just by connecting the probes onto them. So it's a lot easier to test a power supply when you take it out of the case. So what we're going to do is, first of all, very importantly, unplug the power connection. Okay, that's very important. We don't want to have any power going into the system when we're testing it. And also we want to make sure that the switch is turned off, although it doesn't really matter when it's unplugged. Then to remove the cover, we just need to take off a couple of these screws at the back. Now you may find you have to use a screwdriver to take them off. These ones are kind of handy. They're thumb screws. Makes life a little bit easier. Okay, so then at this point then we can just take the cover off by sliding it off and lifting away. Make sure you put it somewhere safe, because these things can be quite pointy, and if they fall on your foot, they can be very sore. Okay, so now that we have the case open, we can see that the power supply is located here, and it has a bunch of wires coming out of it, going in various different directions. So let's trace some of these, right? So one of the wires that's coming out is this one here, or this set of wires, and this is going to the graphics card. So in this case, this is what's known as the PCI Express power connector. So if we're going to take the power supply out, we're going to need to disconnect this one, and there's a little tab here that we need to press in. I'll just zoom in a bit on it so you can see it a bit better. Okay, so just here is this little tab, so we need to press this in before we try and lift it out. We just pull it, and there we go. There's our EPS, our PCI Express connector. The next one then we want to disconnect is going to be over here, and this one is, I'll just shine a little light on it. This one here is the actual EPS connector. So this is EPS, or auxiliary power, that goes into the motherboard. So we'll take that one out. Same thing with this, it has a little tab on it that has to be pressed. So I'm just going to squeeze that and pull that one up. So there we go, that's EPS connector. Sometimes these have 8 pins and sometimes they have 4. So in this case, this one has 4. You might notice it's actually going into an 8-pin socket down here, but that's actually okay. It just goes into the right-hand side of that socket. Okay, so next then we have the main ATX power connector. So this one here. Now this is probably the trickiest one to get out because it does take a little bit of force. So we're just going to reach in here, and there's a tab on this again. You can see the tab is located just here on this side of it. So it's a little bit hard to see. So we need to squeeze that in and then pull up the plug like that. Now, if you find it difficult, just take a little break and try it again in a couple of minutes. Sometimes it can be a little bit frustrating getting these things out, but it's better to take a break and take another look at it rather than using too much force and possibly breaking it. So next we want to look at the power connectors going to the disk drives, and in this case this is the optical drive or DVD drive. So I'm going to just pull out the data cable first. So the data cable is the smaller cable out of the two. That's this yellow one here. And sometimes these have a little metal clip that you need to squeeze before you take them out. It's very important you squeeze those, because if you don't, you could damage the socket that these connect into. So always make sure to squeeze them. And then here's the actual power connector itself. So we just pull it out kind of pretty much straight out like that. And you can see it has a kind of an L-shaped hole in it, and that's how it fits on. That's how you line it up. So you have to make sure it's the right way around, otherwise it's not going to go on. Okay, and then coming down here to the hard drive. So the hard drive is located down here. And again, we have another data cable, so I'm just going to take that one out. This one doesn't have a clip this time. It just comes straight out. No clip on that one. Okay, and it also has an L shape on it as well, so you can line it up correctly with the way the drive is. Okay, and then down here we have the power connector for the hard drive. So that's that one taken out. So we have all the connectors taken out now. So next we need to remove the 4 screws from the back of the power supply. So there's one here, one here, one here, and one here. So we just use a Phillips screwdriver, that's a crosshead screwdriver, and we start taking them out. Taking the screws out, just make sure to support the power supply so that it doesn't fall out when you have the machine standing upright. So removing the power supply is fairly straightforward. We can push it from here just in a little bit, and then we can tilt it. It kind of comes clear of this little shelf there, and it should be able to come out. Now it depends on the type of case you have. Some cases are bigger than others and have more room. So this is a fairly large case. You may come across much smaller cases, which can be a little bit more difficult to work with. Okay, we now have our power supply out. Okay, so we now have our power supply out. What we want to do is we want to look at the different voltages on the different pins in the power connectors. Okay, so to do that, we're going to use the multimeter. Now, just another little safety point. Inside these power supplies, there can be some very dangerous voltages, particularly when they're plugged in. So never ever open one of these when it's plugged in. And also, unless you're qualified to do so, I would seriously suggest not to open these because there are capacitors inside which can hold quite a dangerous level of charge for quite a long time. It can be several months in some cases. So if in doubt, don't open these. Okay, but testing them is perfectly fine if you're just using a multimeter and you just want to check the voltages there, as long as you're careful. Now, some PC cases can be a little bit more tricky to take the power supply out of. This is just a smaller case. It's a nice, neat little case, but it is a little bit harder to get at some of the components inside. So in this case, trying to get in at the auxiliary power connector is okay, right? This one. But trying to get in at the main ATX power connector, it's hidden underneath here. So sometimes you have to remove the hard drive to be able to get access. This particular model doesn't have a power connector for the GPU. So that's one thing we don't have to worry about. But in order to get at this, you may have to actually remove part of it or take the drives out. Some systems don't have a removable plate here. Some do. So I'll just show you with this one how that would work. Now you can see it's a lot easier this time to get into the ATX power connector because now we've got some room to actually get to it. But one other thing with this kind of case is the case has some of the wiring going in behind the motherboard. So how do we get that? Right? It seems to be going in here. Well, the way these tend to work is you'll find that on the other side of the case, there's a kind of a bulge in the case, and that's to allow wires to travel from one part to the other underneath the motherboard. So what we need to do with this is to take the screws out of the side panel on the other side of the case, and then slide that off as well. And then here you see that our wires are going this way. Okay, so to remove them, you would just unplug them as before, but then this time feed them out through this part of the case, and eventually you get your power supply out. Okay, so now that we have our power supply out, how are we going to test the actual voltages? Well, the first thing we need to think about is this plug here. This is the main ATX power connector, and this actually has all the different wires at all the different voltages going into it. And so this is the handiest one we can use to check whether our voltages are correct. But how do we know what voltage is coming out of which one of these pins? So that's where we're going to lead on to the next part, which is where we look at this screen here. And this shows us a schematic of the ATX power connector. And here we can see all the different voltages that should be coming out of the different pins. So for example, this top left corner here, it's a kind of a square pin, and it should be an orange wire going into it, and that should be 3.3 volts. Now what do you do in the situation where all your wires are black? Well, in that situation then you have to base it based off of where it is on the plug itself. So if we're looking at the plug, you can see there's the little clippy bit, the bit that you push in when you're trying to pull the plug out, is shown here. So when you line up your plug, like as we have over here, this is where the clippy bit goes. And then from there we can see that this one here would be the 3.3 volts. Whereas, say for example, these ones down here, these two down here are the yellow ones. So they would be pin 10 and pin 11, and they would be 12 volts. Okay, so we start with pin 1 up here, and then we go all the way down to pin 12 down here, and then we go up to pin 13 up here, and then down to pin 24 down here. So we'll keep this picture in mind, so when we're measuring our voltages, we'll be able to test to see whether they're coming up with the right values. To test our power supply, we're going to need to fool it into believing that it is connected to a motherboard. So we're going to need to use a little hack, and that is to take a straightened out paper clip and then connect it into two of the connectors on the plug. Okay, so one of the connectors is going to be connected to this green one here, which is the PS on pin 16, and the other pin has to connect to ground, so one of the ground pins. So if we were to look, we can just open up our little image here. We can see our different pins. Okay, so I'm going to connect it to pin 16 and pin 19 because pin 19 is ground. So here is the green one is pin 16. I'm just going to pop that in there, and then pin 19 is just over here, and that is a ground pin, which is black. Okay, so once those two are connected together like that, we're just fooling it into thinking that it's connected to a motherboard, and that should allow it to stay on. The next thing we're going to need to do then is we're going to need to actually turn on the power supply. So we have to make sure it's plugged in, and the switch is then turned on at the back. And once we turn it on, it should be possible to test. So when we turn on the switch, we should find that the fan starts turning, and that means that it's working. Okay, so I have my system set up now. I have my ATX power plug here, being held by a little desk clamp. I have my multimeter here ready to read, so I'm just going to turn that to 20 volts. And I'm going to turn on the power supply now, and you'll see the fan go on once it turns on. Okay, so now we can test the voltages. So with the multimeter, there's two probes. The black one is for ground, or the negative terminal, and the red one is for the positive terminal of anything. So if we look at the list over here on the left of the different voltages that we should be reading, we can see there are black ones, and the black ones are grounds. So what we need to do is we need to compare one pin against ground. So that means we're going to be putting the black lead into one of the ground pins. So I'm just going to pick this one on the end here because it's probably the handiest. And the next thing I'm going to do is I'm going to start from the top left, and I'm going to start measuring up here. So when I put the red probe into the top left pin, I get 3.25 volts, which is actually not too bad because it's meant to be 3.3, so 3.25 would be acceptable. Okay, and then all you have to do is just leave the black probe where it is and then go on to the next one. So the next one then is also 3.25, which is close enough. Then if we go into the next one, that's ground. So ground should appear as 0 because I'm comparing ground to itself, so it should just get 0 because it's the same. The next one then, moving on to pin 4, that should be 5 volts. So 5.17, 5.18, that's not too bad. It's pretty close to 5. Moving on to the next one then, we get ground again. Okay, that's pin 5. Then pin 6, we get 5 volts, so 5.14. Then pin 7, we have ground again. Then pin 8, we have PG, which is 5.16, that's okay. Then we have pin 9, which should be 5 volts again, so it's pretty close. Then we have pin 10, which is 12 volts, and 11, which is 12 volts. Again, they're not quite 12, but they're close enough, they're not too bad. And then 3.3 volts down here, so this is 3.26, so that's pretty good. Again, it should be the same up here again, because they're all coming from the same, so 3.25. So then we should have, on this one here, this should be minus 12 volts, okay? So we're getting minus 11.55, so that's pretty close. All right. Now, if you had your pins, your probes the wrong way around, so if I put this probe in here, I put this one in ground, that voltage, which should be coming up as a minus, is coming up as a plus. And it's just because we have the probes the wrong way around. So just to make sure we have them the right way around, I always put the black probe into ground and then the red probe testing the various voltages. So 11.55, that's not too bad. All right, so moving on again, this one here should be PS on, that's fine, should be getting nothing there. That's ground, that's fine. And then we go down to this one here. There's nothing in this one. This is actually an empty pin. There's nothing there at all. All right, so then we go to the next one. 5.17, 5.17, and this one, 5.17 as well. So overall, not too bad. I mean, it's not the most amazing power supply, but it's pretty close. So that means that, at least in the ATX section anyway, the ATX plug, everything seems to be working fine. Next I have the EPS connector, and on this one actually, we just have two different colored wires. So we have yellow and black, and the yellow stands for 12 volts or plus 12 volts. So it's pretty easy to check. All we have to do is put our probe, black probe, into the ones on the right hand side because they're the ones that are connected to the black wires. So just in there, and then we can check, and it's coming up with, interesting enough, yeah, 12.26. Same in the other one. Yep, so that's that okay. Here's the PCI Express connector, and again, it's the same black wires on one side, yellow wires on the other side. So I'm just going to put the black wire into ground and then test, and we're getting 12.25 again. So all of these seem to be fine, no issues there. Next one I'm checking is just the Molex power connector. So this one has red wires, black wires, and yellow. So the red is for 5 volts and the yellow is for 12 volts. And so these are used for powering drives and other things like fans. And usually what happens is the 5 volts is used for controlling or for powering electronic sort of chips, things like that. And then the yellow wires, which is 12 volts, are for powering things like motors, which need a bit more power. So we just put it into the center pins, and then we can check the 5 volts there, and that's coming up. Yeah, same as before, 5.17, and then this one should be 12.25. Yeah. Okay, so that's our Molex connector. Okay. Now, interestingly enough, one of the things I noticed when I started looking to test the SATA power connectors on this is that one of them is damaged. It's missing a bit off the side just here. And also you can see it's kind of warped. If we look real close into it, you can see that there's a little bit of green verdigris there, which is oxidization. So this is not good, right? If we look also on the side, you can see more oxidation just in here. So this was at some point going to turn into a problem, if not already. However, we may as well test it anyway and see, does it work? So it can be tricky trying to do these ones because you don't want to go sticking probes in there. You could end up shorting out part of your power supply. You know, one thing you don't want to do is connect ground to positive using the pin, right? Because the probe here is a piece of metal, and if you put a piece of metal across a positive and a negative, you short out your circuit, and that's not good. That can create sparks and cause fuses to blow and things like that. So what I'm going to do is I'm going to put it into this clamp here, and then from there I'm going to take a measurement. So I'll be right back. Okay, so we have the orange wire here, so that's 3.3 volts. We have a ground wire here. We have the red, which should be 5 volts, and then we have another ground, and then we have the 12 volts. So what I'm going to do is touch the probes off the metal points here on the outside of the plug. That means we don't have to push it into the plug, which would be risky. Okay, so not all of these SATA connectors may have these, but in this case they do, so this is how I'm going to measure it. So I'm going to connect this probe to the black one, okay, and then this one is going to go to there, and yet we can see 3.26, the same as we were getting before. Okay, and then we're going to do the same again, but I'm going to swap over the probes now, and this time I'm going to connect the black one to here, and put this one where the red one is, and we should get, it's moving a bit on me. There we go, 5.17. And then if we move it again, leaving the black one now in this one here, and the red one here, we get 12.26. So power is getting to it all right, but this plug is probably not the best. And I wouldn't recommend using this with an actual hard drive because you could short out your hard drive. So how might oxidization like this happen? Well, that's a good question. Could have been due to a lot of humidity in the area where the computer was being stored, or maybe damp, or alternatively, maybe a little critter got stuck inside the computer and had to go to the toilet. Who knows? But definitely moisture like that is not something good when it comes to power supplies. Okay, so the final method, method number 4, for this method, we can use one of these testers. So you can buy these testers for about $15 or $20, and they allow you to test the power supply fairly easily by just connecting the various parts or various plugs you want to test into it. So what you normally have to do is you plug in your main ATX power connector in here, because this is actually how the device gets power. And then we plug in the various other connectors in here. So say, for example, this one here is the PCI Express power connector. This one is for the EPS power connector. And this one is for a floppy drive power connector. In here then we have Molex, and over here we have SATA power. So right, I'm just going to connect it up and then we'll see what happens. So we're going to get our different connectors. This time we can take out the pins that we use to short our power supply, because we don't need to do that anymore. So this will go into here, just like this. Okay, that's that part. And the next thing we want is to take our auxiliary power connector, EPS, and we can connect that in here like this. So again, it can test 8-pin or 4-pin. So this happens to be a 4-pin one. It in there. And once we turn on our power supply, we should be able to see what happens. Okay, so I'm just going to switch on the power supply. There we go. Okay, so the device gets its power from the supply itself. And here we can see different readings of the voltages that we're getting. So it's showing for minus 12, we're getting minus 12.4, plus 12 is 12.4, 5 volts, VSB is 5.1, we're getting 5.2 volts on the 5 volt supply, and 12.4 and 3.3. So not too bad. The 12 volts is a little bit high, 12.4. It's probably is usable, but it's not the best power supply, so I suppose it's not going to be terribly accurate. But it's pretty handy. That allows us to test that. So we'll just switch it over now and we'll try out the PCI Express power as well. Okay, so I plugged in the PCI Express power and you can see everything is fine again. So that's all good. There's a little PG value here, by the way. That stands for power good. And it's a signal that indicates power supply unit has stabilized all its voltage outputs and is ready to send power to the motherboard and other components. So generally speaking, this should be having a value of between about 100 and 500 milliseconds to be, okay. So that's well within there. Okay, it's 270, so that's all good. Now I'm just going to disconnect the PCI Express and I'm going to connect up both the Molex and then I'm going to test the floppy drive power as well. Okay, so I'm going to connect the Molex connector into the Molex power tester. And then I'm going to turn it on. Now you'll find that when this happens, we get an error, okay, and that's because it needs to have the auxiliary power connected in at the same time. We're just getting LL there, okay. So I'll just turn it off again for a second, and then we shall put in the EPS power connector as well. Pop that in, and then we can test it. And you'll notice that lights come on here for plus 12 and plus 5 because the Molex power provides the plus 5 and the plus 12. So that's what it's showing here, that that's coming through okay. So the floppy drive connector is next, so we'll just put this on here. Make sure we get the pins right, we don't want to bend them. There we go, push that on, and then turn on the power. And that's coming up fine as well, plus 5, plus 12, so that's all good. And then the last one we need to put in is the, actually this one has to stay in. Next one we need to put in is the SATA power. So we have one of the SATA power plugs on this power supply is still in reasonably good condition. So I'm going to connect this one up. So this goes here. Now interestingly, there's no L shape here, but we can sort of work it out from the fact that if we look at our plug here, it's not great, this plug, but if you look at our plug, the little bit that sticks out there is going to be, pointing towards the deeper area. So just connect this up here like this, put it in. Okay, and we got this in as well. So let's turn it on and see what happens. Interesting. So it's giving us our 12 volts and our 3.3 volts, but it's interesting, it's not giving us the 5 volts. Oh, it is now. I just plugged it in a bit better. Oh, it's a little bit loose though. Okay, so we can see it's not a great connection there. Okay, but as I suspected, this plug is not great, and this is the best one out of the 3 that came with this particular power supply. So the SATA connectors in these are not exactly fantastic, but there you go. All right, so that's pretty much it. We've done 4 different ways of testing our power supply. One with the BIOS, one with the software using HWInfo. Another one then is to use the multimeter, and then finally one of these power testers. These are really handy if you're doing a lot of testing of PCs. They're quick and easy to use. They may not be terribly accurate, but they're not bad though. They're quite handy. So I just thought I'd show you one more power supply that I had, and it's kind of amusing because in this particular one, when we turn on the power supply, we use the tester, there's a little bit of a hiss coming out of the power supply, but then as well, when we look at the display, the voltages keep fluctuating, in a fairly large amount, and it's giving us a 0 for the power good on the power supply. So that's where these come in really handy. They can point out things that maybe a multimeter mightn't be able to show you. So yeah, this power supply is not good, and I have a suspicion that the reason for that is probably because the capacitors inside it have become faulty. So I'm going to open it up and we'll take a look. So I've taken the lid off, and we can see here that there's two of these large capacitors inside, and these are used for smoothing. So basically for removing sort of AC ripple and just giving you a nice smooth DC voltage coming out of your power supply. But in this case, one of them seems to be bulging outwards. But the other one looks okay, even though it has a red mark on it. That's just from a marker. But this one here is bulging. The top is bulging. That's usually a sign that a capacitor is failing. So to fix this power supply, you need to replace this capacitor. However, as I said before, unless you know what you're doing and you're kind of qualified to do so, you shouldn't open up these power supplies because you can get a really nasty shock from those. And also, you know, when the power supply is connected to the mains, you can see over here, you have connections that are directly connected to your mains coming in. So very dangerous to touch any of those. Okay. Okay, folks, just a couple of quick safety reminders. So remember, never open a PC power supply unless you're qualified to do so. Always make sure to unplug your PC before removing the power supply from it. Check that your power cables and the power supply unit are not damaged before testing, because, for example, one of the power cables might be damaged or frayed somewhere or worn, and maybe you could get a shock from that if you're not careful. And then finally, wear safety glasses when testing circuits. Okay, folks, thanks for watching. I hope you enjoyed the video. Please feel free, if you're feeling generous, to leave a like or a comment. And again, thanks for watching. See you next time.